This video is going to include examples from section 1.R.9, which is about multiplication and division with real numbers. So earlier we did multiplication and division with fractions or rational numbers because they're a ratio or a quotient is the other word of two whole numbers or two integers. Real numbers are the number line numbers. Any number that can be represented in decimal form is a real number. And any real number can be represented in decimal form. It's kind of the same thing. Some decimals are repeating, some decimals are non-repeating, so there's no pattern in them, but or there's no obvious pattern in them. So we're going to do 15 examples here. The first one is kind of wordy. The quotient of a number divided by 0 is blank. And that's always undefined. So that's our word for the result when you divide by 0. And that'll be one of the choices on Hawks very often. So the number 2, I got 1 times negative 30, and anything multiplied with 1 is just whatever that number is, in this case, negative 30. So there's some quick ones at the beginning. 6 times 0 times negative 2. Now, you can do the first two and then whatever that product is multiplied by the third one, or just notice there's a 0 there. Whatever it is, it's getting multiplied by 0, so the result is going to be 0. Several of these problems include fractions, which are real numbers, of course. Some of them, as we just saw, include just whole numbers, which are also real numbers. This one, negative 6/7 times 4 times 3/4, is kind of a mix of those two. There's a whole number, but we're also multiplying it by two fractions. We don't have to do the common denominator thing because we're not adding or subtracting. It's just multiply across the top and multiply across the bottom, but we can make this a little simpler. If you notice, we're multiplying by 4 and dividing by 4. And those two operations are going to cancel each other out. So I'm just going to cross those out, and then this is like 3 over 1. And even this 4 is like a 1, but that it doesn't change anything. Across the top, negative 6 times 3 is negative 18, and across the bottom, 7 times 1. The next one, also fractions, 10/21 times negative 35/9. And I'm going to do something similar here to simplify before I multiply. That way I don't have to work with large numbers, or the numbers will be small as possible. These two have a common factor of 7. 35 is 5 times 7. 21 is 3 times 7. So if I cancel that 7, it leaves a 5 there and a 3 here. And that's all the canceling I can do, because in the denominators of these fractions, there are only factors of 3, 3 and 3 times 3. And up here, there's only 2 and 5. 10 is 2 times 5 and that 5. But there's a negative sign. So my numerator is going to be negative. 10 times 5 is 50. 3 times 9 is 27. And that's it. For number 6, I got 2 decimals, negative 5.94 times negative 0.69. And you can type it into the calculator just like that, but you can save yourself a little bit of time if you notice that we're multiplying a negative times a negative. So those negatives are going to cancel, and you don't need to type that each time. With these numbers, 5.94 and 0.96, you don't have to use parentheses because there's no negatives. You can just type this number times this number, and you should get 4.0986. And try that out on your calculator to make sure you're using it right. And to make sure it works. For number 7, I got negative 56 divided by 4, and I don't know negative 56 that well, other than it's an even number, and I know 4 is an even number. So if we cancel out a factor of 2 from each of these, 56 divided by 2, or half of 56, is 28, and half of 4 is 2. So that's a little bit simpler. I don't want to forget the negative, though. That's the whole thing. Oh yeah, that's the whole problem. Just to simplify that. There's another factor of 2. 28 is 14 times 2, and well, if I cancel that 2, I'm left with a 1. But the way that I need to complete this, to simplify it really, is not to write it as a fraction anymore, because negative 14 over 1 is negative 14, and that's the completely simplified. For number 8, the problem said in a sentence, I'm just going to write it as average of the following list of numbers. So we want to find the average or the mean of 37, 72, 26, negative 21, and negative 79. So the average of those 5 numbers is what I'll get by adding them all: 37 plus 72 plus 26 plus negative 21 plus negative 79. Add all those numbers up and divide by the number of numbers, which is 5. There's 5 different numbers there. So the average is what you get by adding the numbers together and dividing by how many there are. In this case, you can do this as 37 plus 72 plus 26 minus 21 minus 79, and that's easier to type in, but you need to hit enter on your calculator and then divide by 5 to divide this whole sum by this number. Another way you can do that is to use parentheses for the whole numerator and then divide by 5. And this is a way that you can type it in all at once. The result should be 7. And that seems kind of weird to me because these are all 2-digit numbers and the average is a 1-digit number. What's going on is these ones are bringing the average way down because they're actually negative 2-digit numbers. For number 9, I got negative 2 over 21 divided by 7 over 27. And just like before when we did multiplication and division of fractions, negative 2 21st times 27 sevenths multiplied by the reciprocal of the divisor. Here, these two numbers each have a factor of 3. And I'm going to cancel that. So if I take a factor of 3 from 27, 27 is 3 times 9. And 21 is 3 times 7. What's left upstairs is negative 2 times 9. And downstairs, 7 times 7 is 49. So negative 18 49ths. For number 10, whole numbers again. 2 times 2 times 4. It's fine to do this in the calculator and it's quick too. But if you think about how we're doing our math, this is going to come up in a later section. We work from left to right. The first thing to do here is multiply 2 times 2. That result is 4. And then that 4 times this 4 is 16. So it's really a one-step problem, even if you don't. I suppose you could write down 4 times 4 and then equals 16, but whole numbers are nice like that, especially the number 2. Very small number, easy to work with, easy to multiply by, and easy to divide by, compared to the other numbers, that is. But it's For number 11, I got negative 4/5 times 8/11. And there's nothing that I can cancel there. There are no factors of any of the numbers upstairs that are also factors. Well, the only factor upstairs is 2. 2 times 2 times 2, and 2 times 2. Down here, it's two prime numbers, 11 and 5, so there's no common factors. This is negative 4 times 8 is negative 32, over 5 times 11 is 55. Here's another one with decimals. And again, it's a negative times a negative, so the result is going to be positive. And I don't need to type those negative signs because they cancel each other out. But 58 times 18, that's not something I want to do. I'm going to type that into a calculator, 5.8 times 1.8. You can do it with just the whole number, 58 times 18, and then move the decimal place twice, because there's 2 decimals. But calculator is fine. And this should give 10.44, positive 10.44. 13 is another average problem. I'm supposed to average the numbers negative 98, 97, 65, 24, 3, 38, and 95. So that's 1, 2, 3, 4, 5, 6, 7 numbers. I'm going to add them all up. You may not even really need to write this expression down, because it takes about the same amount of time to write it as it does to type it into the calculator. And all I'm doing is adding all these numbers, one of which is negative. That's important. All the other ones positive. Yeah. Add those all up and divide them all by 7, or divide the sum by 7. And the result should be 32. That's the average that I'm looking for this list of numbers is 32. We saw this next type of example at the beginning with number 1, but this time it's just written in symbols, 5 divided by 0, and what is that? It's not a real number. Real number you can divide by any non-zero number, but dividing by 0, the result is undefined, so that's the answer. And then 15 is about mean height. So it's kind of an applied problem or a word problem. Mean. Mean is a technical name for the average. So it's you add the numbers together and divide by the number of numbers to nearest 10th. So the 10ths place is the first decimal place to the right of the decimal point. We're gonna get a result that's got a lot of decimal places, but we're gonna round it to that first decimal place. All right, so height. I'm gonna build this little table that they gave me, and this is in inches. 65, 71, 73, 74, 75, 77, and 79. Okay, those are heights. Now, I don't just have those individual numbers, though. In this next row are given the frequency, which means how many of the people in the group are 65 inches tall. In this case, it's two 65-inch tall persons, one 71-inch, one 73-inch, two 74-inch, two 75-inch, six 77-inch, and five people are 79 inches. So there's 7 different heights there. There's 7 different heights in this list, but there's way more than 7 people. There's 2, 3, 4, 6, 7, 8. 8 and 6 is 14. 14 and 5 is 19. There's 19 people here. So what I have to do is add up 65 twice. 171, 73, 74, and another 74. 75 and another 75. 6 77s. So 77 plus 77 plus 77 and so on. And then 5 79s. And doing it that way with your calculator, it's tedious and it's too time consuming. So here's what you should do. To find the average of these numbers, remember there's 19 individuals. What I need to do is 2 times 65 plus only 1 times 71. I'm just going to write 71. 1 times 73, that's just 73. Plus 2 times 74 plus 2 times 75 plus 6 times 77 plus 5 times 79. Like I said, this takes as long to write out as it does to type into the calculator. So if you know what you're doing, you can just go ahead and put your numbers, this times this plus this times this plus this, and so on, and go through, work your way through the table. If you're still learning how to do this, though, this is a frequency table. So maybe if this is your first frequency table problem, you should probably write it down. It's not just this, but this divided by 19. And that's the average for this frequency type table, the average height. To the nearest 10th, I'm going to write it down first. I did the top part separately and I got the number 1429 over 19. But that's 75.2105263. That's a lot of digits. We want the nearest 10th, so 75.2. There's the 10th place right there. And since this next digit is a 1, I'm not going to round this up. I'm going to leave that at 2. What we did there was we actually rounded off the rest of this from the hundredths place onward. We rounded down to the nearest 10th because the nearest 10th was a little bit below.